Okay, so we're going to be exploring the logistic function within Desmos, and I've created a little applet that we can go through with different pages and explore different parts of this logistic equation. So with the logistic equation, the main thing that most mathematicians look at is the growth and decay. So before we look into growth and decay, we're going to look over here with we got sliders that will change the direction of our logistic function in different ways, and then we got A, B, and C as up here in our function. We got A, then we got B, and we got C. So right now they're all at 1. So this is our base logistic function. So this is the function you get with everything being 1. So the thing we need to look at here mainly is this negative B. So we got to be careful. So when the B goes into the negatives, it's actually a positive. So let's start by changing A. So if we got positive 1, so we move it up. Our logistic function grows. It just moves upward. And if we go down, it goes down to the negatives, which makes sense because since A is positive, so say we got 2, it moves up, so it's in the positive direction. And we drop it down to say negative 2, it drops to the negative 2 in the negative direction. So let's put A back to 1 and let's explore B. So move B, it's changing our little curve here in between the middle. So if we move it positive, it looks like the lines are getting closer to each other. It's decreasing that little increasing. So if we go to negative, so we got to remember here, so we got 5, but it's technically negative 5 because we got that negative there. So, but however, even though it was a negative, this still is going in the positive direction. So we need to be careful with that. So if we go down to, let's say, negative 3, notice our line switch directions. So we were going from negative infinity to positive infinity. Now we drop it to negative 3. We're still going from negative infinity to positive infinity, but we have a decreasing factor instead of an increasing. So let's drop B back to 1 and let's look at C. So C looks like it just drops it closer to that x-axis or farther away from it. So if you look, it's like a little wave motion if you move it back and forth. So the more you move it this way, the more our increasing value will move to the right or to the left. So looking at this, let's explore this a little more in depth. So now, without graphing, now that we've looked at all 3 of our values, so we got 2 as our A value. So we got negative x. So our B value will be negative 1, and we have no C value. Okay, so we got 2 over 1 plus e to the negative x. So without graphing it, as we learned last time, this 2 will just move our graph up or down. And so if we're looking at growth and decay, the main thing we need to look at is that B value. So if it's in the negatives, so we got in the negatives, which is going to make this a positive. So our growth and decay, we're going to have a growth. And since we got this 1 plus e to the negative x, we're going to have a growth going upwards. And we can just graph it right here. So we got the 1 plus, so we're going to mark it right here at the 1. And then we're just going to do a little graph of it. So it's going to go something like that, not quite that high. And then it's going to come down here to the y-axis and stay, or the x-axis, and stay on that x-axis. So we can erase this and just move it down. We're just trying to see this growth right here. We're on the next one. Another thing we can explore is limiting values, such as horizontal asymptotes. This logistic functions will never have a vertical asymptote because it always goes from negative infinity all the way to positive infinity. So you can never have a vertical asymptote. However, you can have a horizontal. More likely you'll have 2. One being your x-axis, because this line might look like it's going to touch the x-axis, but it never will. And then you're going to have a line somewhere right through here. It looks like in this case it's going to be 1, because since that's 2, you're going to have 0.5, 1, and so forth. So let's change some values and see which values change or determine our horizontal asymptotes. So if we change A, our A value is moving up. So therefore, it will change our horizontal asymptote, because if we had it at 1, our asymptote's at 1. Moved it to 2, our asymptote moves up to 2. So if we keep looking, we're going to move on to the other 2, but we need to keep this in mind that every value of A looks to be a horizontal asymptote. Because then we have it at 3, and then we have it at -2. So let's put this back to 1. Let's look at B. So we move B up, and B is just moving this graph this way. Even though it switches directions, our asymptote is still going to be at 1. So let's move A. All it's just moving that graph right back up. So that would be a horizontal asymptote. So B has no effect on the asymptote. Move A back to 1. Look at C. So we move C. Now C is moving it down from what we can see. But if you can still see over here in the corner, it still is moving upwards. And it's going to keep going all the way until infinity, until it reaches a point where it stays. It's always going to increase just a little, but it'll never touch that horizontal asymptote. So always going to have that 2. Eventually it's going to go up to 2. Or, well, in this case 1. I'm sorry, because right here. But if we move that up to 2, no matter what you move C, it's always going to continue to increase. You can see right here that it's never going to pass that 2. So C has no effect. So after looking at all 3 values, A will be our a letter that determines our asymptote. So now our next question we're going to look at is which value determines rate of change. So rate of change is pretty much when this graph switches directions. So right now we got a positive rate of change. It's going in the positive direction. So if we look at A, we know A is a horizontal asymptote, and A never changes directions except when it goes into the negatives. So we look at B. B just moves the middle, but if we go to the negatives, that's when it switches directions. So right here we're going from negative up to positive. So then we go down here, we're going down from negative to positive. So we look at C. C's just moving along the graph. So our letter that changes our rate of change will be our B value.